All right, 8, 7, where did it go? That's it, there it is. There we go. All right, 8, 7 math. We are on lesson 24. Lesson 24. Lesson 24, reducing fractions. Reducing fractions. So this is part 2 of the reducing fractions. So example number 1, we have using prime factorization to reduce 420 over 1050. Okay, so example 1. So first and foremost, we need to find the greatest common, oh wait, no. So 420, looking ahead, 420 over 1050. Okay, so we need to factor out both 420 and 1050. So let's first factor out 420. So I'm going to do a factor tree, which we've just learned a little bit ago. So what goes into 420? Well, 42 and 10. 10 can still be factored out into 5 and 2. 42 can be factored out to 7 and 6. Yeah. And then from there, 6 can be factored out into 3 and 2. And I'm done because nothing goes into 7 besides 1 and 7, and nothing goes into 5 besides 1 and 5. So for 420 in my numerator, I would write 2 times 2 times 3 times 5 times 7, because I have a 2 right there, so I'll cross that out. A 2 right there, a 3 right there, 5 and 7, because those are my last numbers that I factored. So if I were to take 2 times 2 times 3 times 5 times 7, that would give me 420 if I were to go all the way and do that. Okay, so that's what we're doing. Yes. Yes, I do. So I'm blind as a bat. I do, yes. So now we need to do the prime factorization of 1050. No, because I need to get through this. 1050. So I'm going to factor tree it up. So since there's a 0 at the end, we know 10 goes into it. 10 times 105. 10 times 105. We know 10 factors out to 2 and 5. What does 105? What goes into 105? William?
5 is.
Yep, 5 and 21. 5 and 21. Am I done there, Aries? What else? Yep, 7 and 3. Now I'm done because nothing goes into 2, nothing goes into 5, 7, or 3, except for 1 and that number. So I have 2. 2 is one of my final numbers, times 3. 3 was one of my final numbers that I was able to factor out. I have 2 5s, so I have to write down both of those, and then I have a 7 here at the end. So why did I do this? Why did I do this? Well, I need to see, out of everything that I have right there, I need to see which ones are going to cancel each other out. So right here we have, I'm going to use a highlighter. So I have 2 and 2 right there. So those two will cancel each other out. I have a 3 and a 3 right there. Those are going to cancel each other out. A 5 and a 5, those will cancel each other out. And then a 7 and 7, they will also cancel each other out. So what am I left with in my, what am I left with, Caleb? What am I left with? So I have a 2 in my numerator, right? And then in my, so I'm left with 2 over 5. 2 over 5, or 2/5. So my fraction that I'm left with is 2 over 5. Okay? So now I need to, now it wants me, for part B, it wants me to find the greatest common factor of 420 and 1050. Okay, so how would I do that? Bethy, you have your hand up, or you? So what is the greatest common factor between 420 and 1050? Would it be 10? Well, how would we find out? How would we find out? William? By doing the factor tree. Yep. So when I had my factor tree listed out, what was my greatest common factor between the two? Well, let's see the ones that I have in common. I have a 2, 3, 5, and 7. So what I would do is I would take 2 times 3 times 5 times 7. See down here how I have those highlighted ones? A 2, 3, 5, and 7. So those are the ones I have in common. If I multiply those all together, that'll give me my greatest common factor. So 2 times 3 is going to be 6. 5 times 7 is going to be 35. And then I'm going to multiply 6 times 35. So 6 times 5 is going to be 30. 6 times 3 is 18. Plus 3 is going to be 21. So I have 210. 210 would be my greatest common factor. So this is what we did for part B, and part A was finding 2/5. So first thing that you need to do is do the factor tree for what's in the numerator, which in our case was 420, and then we would do a factor tree for what's in our denominator, 1050. Okay. And then once you do that, you're able to write out what is left in your new, or what is left after you were factoring out. So from 420, I had a 2, 2, 3, 5, and 7 was in my numerator. In my denominator, I was left with a 2, 3, 5, 5, and 7. From there, I was able to see what was in common. The 2s were in common, so those canceled out. The 3s were in common, so I canceled those out. The 5s were in common, cancel them out. 7s in common, cancel those out. So I was left with 2/5. 2/5. So that was my, through prime factorization, I was able to find out that 2/5 was left over. And then through canceling out, I used 2, 3, 5, and 7. That's what I did to, when I multiplied them all together to find my greatest common factor of 210. All right. So let's try another one here. So reducing before multiplying. So this is the one you were asking about, William. Example 2. Example 2. I think you figured it out after you looked at it. So our example that we have is 9 over 16 times 2 over 3. 9 over 16 times 2 over 3. Yeah, William.
So what I did was I took from each side the top, and I divided by the other fraction by the denominator.
Mm-hmm.
So you divide the numerator by the denominator with a separate fraction. So 2 and 16 would be 8, and 9 would be 3.
Right. So what William's saying right here is when you're able to reduce before multiplying them together, as you look at the ones that are in common, that are diagonal from each other. So the yellow ones are the ones that we always reduce from, and then the blue ones are the ones that we always reduce from. the ones that are across from each other, okay? So this is how it would be right here, and then the yellow ones right here, right? It didn't. So from there, I can work this out. So 9 and 3, both of them have in common a 3. So when I take 3 divided by 3, that's going to be 1. So I have a 1 right there. When I take 9 divided by 3, that's going to be 3. Now I need to do the blue section, So 2 and 16. What do 2 and 16 both have in common? Aries? 2, yep. So 2 divided by 2 would be 1. And then 16 divided by 2 is going to be 8. Now I'm done. Now I can multiply straight across. So I'm going to write out here what I'm going to be multiplying together. Multiply the numerators together, so 3 times 1, and then I'm going to multiply my denominators times each other, so 8 times 1. And what's that going to give me as an answer, William? 3/8. Yep. 3/8. Okay?
It's not always going to be divided.
Yeah, sometimes you won't be able to. So sometimes you won't have a 2 and a 16. Sometimes it could be a 3 and a 16. And if you have
5 and 8.
yeah, then you wouldn't be able to do anything. Except for the 5 and 10. Yep. Sometimes, like the example. So what's that example in the book that you're saying?
The problems.
Yeah, which one is it? I'll do it up here. So letter D. So letter D we have, so here's one of the examples in your homework I'm going to do. 5/8 times 3/10. Yeah, you can do that. You can start with D in your homework. So here's a free answer. As you can see right here, we have 8 and 3. So we can try and simplify with those. And then we can also try and simplify with 5/10. Oh man, 5/10. So with my yellow ones, this is what William's talking about. 8 and 3, they have nothing in common, so I cannot reduce. 5 and 10, they do have something in common. And what's in common? 5. 5 goes into both 5 and 10. So 5 divided by 5 is 1, and 5 divided by 10 is 2. Now I can't do any more reducing, so I can multiply straight across. So I have 1 times 3 and 8 times 2. So 1 times 3 is 3, 8 times 2 is 10. If you wanted to, you could just multiply straight across. So if you don't like doing it this way, reducing beforehand, you don't have to do this. So you could just do 5/8 times 3/10, and you will get the same answer if you do 5 times 3, multiply your numerators together, and then multiply your denominators together. So 8 times 10. So 5 times 3 is going to be 15. 8 times 10 is going to be 80. And then I would need to reduce from there. So what's in common with both 15 and 80? 5. Divide both by 5. So I would be left with 15 divided by 5 is 3, and 80 divided by 5 would be 10. Wait. That's what I did wrong. Not 10. You guys probably noticed that, didn't you? So 8 times 2 is 16, not 10. I added them together. Yep. So 8 times 2 is 16. Mr. Doomer made a little bit of a mistake right there. So 80 divided by 5, that's 16. That makes way more sense. All right. So you don't have to do it this way right here. You could just multiply it straight across, but it's going to be easier in the long run.
It's telling you in this book you have to do it that way.
You don't have to, no. It's just wanting you to do it for this concept. I'm saying in the scheme of things, when you are doing everything, you don't have to do it this way. It's just, you're going to have to do a lot more steps. They are showing you the quote unquote easier way, the more understandable way. But if it doesn't make sense to you and you want to just keep practicing by doing it this way, I'm okay with that. And then you just have to reduce at the end. Okay? Does that all make sense, guys? All right, so let's try example 3 where we have 3 different fractions. Yes.
Is your way just to multiply across?
No. So example 3, I have 8 over 9 times 3 over 10 times 5 over 4. So what do I do right here? What do I do when I have 3 fractions? Does your mind blow up and then you start banging your head on the table because you're like, I don't know what I'm doing?
Error.
Sometimes we want to do that, right?
Error.
Oasis, what do I do? Can't see. Oasis, what do I do?
The 5 and the 10.
Yep, so you could go from any point as long as you are doing the diagonals. So,
Well, you can't do one number twice.
so what Oasis is saying is we could reduce right here, the 5 and the 10. And if I were to do that, 5 and 10, what do they have in common? They both have 5. So 5 divided by 5 would be, not white, would be 1.
And then
Yep.
10 would be 2.
And 10 would be 2.
4.
So Caleb just said, could I do the 8 and the 4? Why, yes, I could. So let me try and get those connected from far away. So I have 4 and 8. So those are the ones Caleb's talking about. What I can do with those, they both are divisible by 4. So 4 divided by 4 is 1. 4 divided by 4 is 1, and 8 divided by 4 is 2. Can I do anything else? Bethy, can I do anything else here? Yeah, 9 and 3. 9 and 3. Those are both in common. If it works for you, I would definitely have highlighters in this when you're doing 3 fractions and highlight the ones that are in common when they're a diagonal like this. I would definitely do that. I didn't. So 9 and 3, 3 goes into both of them. They're both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Now I can multiply straight across. So take all the numbers that I just have as my reduced number. So I have 2 times 1 times 1. Those are all my numbers left in the numerator. And then in the denominator, I'm left with 3 times 2 times 1. Oh, there was one more thing I could do. Does anyone see one more reduction that Mr. Doomer missed? Yeah.
8 and 10.
Not 8 and 10. I already did those. So what I did here was, so I crossed those out, is I have 2 and 2. I missed that one. So look at these right here, 2 and 2. 2 and 2, they're both divisible by 2. So I would cross those out, 2 divided by 2. So you can have that in some cases. If not, you will just get an answer of 2 over 6. Then you just divide it by 2, and you would have 1/3.
They never told me about that. So I was supposed to figure out why this didn't work. But I kind of guessed when you said there's one more, but say it after I.
Yeah, I missed it too, but that's okay. I was trying to move too fast. So that's the other way of doing it is if you do miss one, you'll just notice that you'll do some reducing there at the end, okay? So I'm okay with you just taking 8 times 3 times 5 in the numerator, and then in the denominator 9 times 10 times 4. But can you see how that's going to be a little challenging? Yeah, that's a lot of multiplying right there. All right, so that's all I have. Oh, there was a bigger one though. All right, I'll do example 4 too. That's a big one. That's a big one. Example 4. Yeah. That'd take a minute. Yep. 27 over 32 times 20 over 63. Oh, yay. Now we're working with big numbers, not just little numbers. Huh? We could, but you're going to start working with bigger numbers, and eventually you'll be working with unknowns like they're doing in pre-algebra right now. You'll eventually work with unknowns where you'll have a 27x and a 63xy. Eventually you'll have stuff like that. But I'm not going to get into that because that's going to get more confusing. Okay, so what you would do first is you could see what is all in common here. So you could just start by saying, so 20 and 32, what goes into both of those? Well, they're both even, so 2. 2 divided by 20 is 10. 32 divided by 2 is going to be 16. And then I could reduce them again. 10 divided by 2 is 5. 16 divided by 2 is 8. Now I'm done with those. 63 and 27, what goes into both of those? They're not even. Can I do anything with them? Bueller, anyone? 63 and 27? I'm surprised no one got that reference.
Oh.
Yeah, William. 3. So 3 goes into 63 how many times, William?
Actually, you can go 9 instead of 3.
9 would work too, but yeah, we'll start with 3.
3,
So 21. 21, 63 divided by 3. Yeah, and 9. So now I can do something else. So William just noticed that 9 goes into both 63 and 27, but that's okay. We can just do an extra set. So 9 and 21, what goes into both of them? 3. So 21 divided by 3 is 7, and 9 divided by 3 is 3. Now I'm done. Now I can just multiply straight across. Now I have 3 times 5 in my numerator. That's what I'm left with. And then I have 8 times 7 in my denominator. So 3 times 5 is going to be 15. And 8 times 7 is going to be 56. And that is my lowest form. Yay, I got the right answer or something. So if you wanted to, you could do it the same way that they did it in example 4. You could just write out a factor tree for each one of those numbers. I think that's the harder way. You have to write out a lot more work. So I would recommend doing it this way. I think this way, if you understand how to do it this way, this is a lot quicker. Caleb, can you stop? Happy feet. So that is it for this. Math 8-7, you guys feel okay with that? Yeah? That wasn't a lot of mm-hmms. I heard pretty much just William.
I said
Nada, don't understand it. Bethy? Courtney? Caleb? They both are divisible by 3, and they're both divisible by 9 too.
Oh, and then how many 3s go into it?
Yeah.
3s? Oh.
Yep. So I took 27 divided by 3, which is 9, and 63 divided by 3 is 21. And then I saw both 21 and 9. 3 goes into both of them. So 21 divided by 3 is 7. 9 divided by 3 is 3. Yep. Or you could just multiply straight across. It'll just be massive numbers.
Way I did more.
Okay. Yeah, that's fine. If you have another way of doing it, I'm totally fine with that, as long as you're getting the right answer. Jaden, are you okay with doing this, or? Yeah? Okay. Oasis?
Yeah.
Meh? All right. So.
I said yeah.
Oh, okay. So 8-7, that's all I have for you. Keep working on your homework. If you're struggling with the practice set, so A through G, just go ahead and skip those ones and keep working through the numbers. So you guys are working on 1 through 23. So keep chugging along.